Hello there, and welcome to the calm space of LUMIVERSE NL, a place where science breathes slowly and the ocean becomes a lullaby. Tonight, we drift into the great blue, the quiet body that covers more than 70% of our planet. It is not just water, it is memory, a living rhythm older than mountains, older than light reflected on the waves. Beneath its surface lies a world without boundaries, a kingdom of motion and silence intertwined. Here, sound travels faster, light bends softer, and time feels unhurried. The ocean holds more life than all the forests and plains combined, yet most of it remains unseen. It is our planet's beating heart, circulating warmth, oxygen, and stories through every current. When you listen closely, the sea has a voice. It whispers through the pull of tides, through the hush between waves, through the deep sigh of the earth's breath. That voice has shaped civilizations, carried explorers, and hidden secrets older than humankind. Every drop of seawater contains traces of ancient stars, sodium, magnesium, and carbon that once burned in suns long gone. To look at the ocean is to gaze into time itself. Beneath that surface, there are mountain ranges higher than the Andes, valleys deeper than Everest could ever reach, and life forms that glow like galaxies suspended in darkness. This is Earth's final wilderness, vast, unending, and alive. As you breathe now, imagine the air filled with its rhythm, each inhale a rising tide, each exhale the retreat of the shore. Let that motion calm you, as if the body itself were part of the ocean's flow. Because in truth, it is. Every heartbeat echoes the pulse of the sea that once filled our veins millions of years ago. The salt in your blood, the water in your cells, all remember that ancient origin. We are not separate from the ocean. We are its continuation, walking fragments of tide and storm, still dreaming of the sound of waves even in our sleep. So tonight, as we descend beneath the surface, let curiosity become calm and learning become rest. We will explore the ocean, not as scientists or travelers, but as quiet witnesses to a world that never stops breathing. Every current tells a story. Every shimmer of light reveals an age. And somewhere, far below, the planet is still whispering, in the language of motion, patience, and depth. Beneath the gentle sway of waves, history sleeps, not on land, but under miles of salt water, where sunlight fades into blue twilight. There, scattered across the seafloor, rest the relics of everything humanity once was: ships, statues, ports, and cities swallowed by time. The ocean, in its stillness, has become the keeper of memory. There are more historical treasures beneath the sea than on all the continents combined. Every sunken ship tells a story of ambition, discovery, or loss. Roman cargo vessels carrying wine and olive oil still lie in quiet harbors beneath layers of silt. Greek triremes, once engines of empire, now rest as coral-covered silhouettes where fish drift through the ribs of history. And deeper still, entire cities sleep. One of them is Pavlopetri, off the coast of Greece, the oldest known submerged city in the world. It has stood beneath the waves for nearly 5,000 years. Streets, courtyards, and walls remain perfectly preserved, protected by the ocean's cool, oxygen-poor stillness. There are doorways that open into nothing, steps that lead nowhere, as though time itself once paused to take a breath and never exhaled again. When divers swim there, they glide through what was once a thriving community, their bubbles rising like ghosts from an age before writing, before memory. The ocean preserves what the surface forgets, because in this silent world, decay slows. Wood, stone, even metal endure for centuries where air cannot reach. Every artifact becomes a time capsule, a message sealed in water. Ancient anchors still cling to sand, Amphorae lie unbroken, their curved bodies filled with the darkness of millennia. Each one holds the shape of a human hand that once set it down. Modern explorers use sonar mapping and underwater drones to rediscover these forgotten worlds. From the Caribbean to the South China Sea, thousands of wrecks are slowly being revealed. Merchant ships, naval fleets, and trade routes that once connected entire civilizations. Some sank in storms, others in battle, and some simply vanished into the depths without witness. Each discovery tells us not only how people lived, but how the ocean shaped their fate. It is strange to think that while we dream above the surface, so much of our story sleeps below it. When we speak of history, we imagine stone temples, ruins in deserts, or ancient scrolls preserved in libraries. But the truest archive of human history may lie beneath the tide. Down there, where the sun becomes memory, the earth keeps our secrets in the dark. Sometimes the sea reveals them, but only when it chooses. A storm shifts the sand, and a carved pillar appears. A fisherman pulls up a bronze coin older than language itself. For a moment, the past rises to the light, then drifts back down again, returned to silence, where it belongs. The ocean's memory is not only human, it carries traces of everything that ever lived. Shells of vanished species, coral skeletons from lost reefs, and sediments that record the pulse of ancient climates. Geologists read those layers like pages of a book. Years of drought, floods, and the slow rhythm of Earth's breath. Each grain of sand beneath the sea once moved in a river. Each fossil once touched the light of a forgotten sun. To explore the deep is to walk through time itself. Every current passes through epochs. Every echo carries the sound of ages collapsing into one. And when the light from your torch strikes the seafloor, you are not just illuminating coral or stone, you are waking the past. Beneath the surface, history is not gone. It is only resting, waiting for patience, for curiosity, for a diver's slow approach. The ocean does not erase. It remembers. It guards its relics with pressure, salt, and silence. It teaches us that nothing truly disappears, only transforms, sinking gently into stillness until we are ready to listen again. So tonight, as we drift deeper into this world of memory and motion, remember this: the sea beneath us is not just water, it is the planet's own library. Its shelves made of sand, its pages written in coral and stone, its words spoken in waves. Beyond the ruins of human history, another kind of story begins, one written not by hands but by life itself. In the deep, the ocean glows. It is a light not born of the sun, but of living creatures that have learned to carry fire within their bodies. This phenomenon is called bioluminescence, and it is one of the most mesmerizing miracles of the natural world. Down in the darkness, where sunlight can never reach, life has found a way to make its own dawn. Tiny plankton drift through black water like scattered stars. Jellyfish pulse with soft blue halos. Squid shimmer with waves of green light, and fish trail ribbons of gold behind them as they move. Every flicker is both a signal and a survival light, used to hunt, to hide, to love. It is as if the sea itself dreams in color. Among these glowing beings lives one of nature's most mysterious creatures, the immortal jellyfish. Its scientific name is Turritopsis dohrnii, and it has discovered something close to eternal life. When injured or old, it does not die. Instead, it returns to its earliest form. Its cells transform, becoming young again, ready to start anew. This process is known as biological immortality. Unless eaten or destroyed, this tiny jellyfish can repeat that cycle endlessly, slipping through time like a living secret of renewal. Scientists study it not just for curiosity, but for insight into the nature of aging itself. How can a creature so fragile defy time? Its secret lies in regeneration. the quiet intelligence of cells remembering how to begin again. The ocean, it seems, is not only a keeper of the past, but a laboratory of rebirth. In this glowing kingdom, transformation is everywhere. Some fish, called clownfish, begin their lives as males. But when the dominant female in their group dies, one of the males changes, becoming her successor. This phenomenon is known as sequential hermaphroditism, a biological flexibility that ensures survival and balance within their tiny societies. It is nature's way of saying, adapt, and life continues. Elsewhere, in coral reefs and kelp forests, this adaptability becomes art. Corals form vast cities of stone and color, each colony a living architecture of patience. Their bodies glow under moonlight, responding to cycles older than any calendar. When the ocean warms too much, they pale a quiet cry for balance. Yet even then, some recover, as if determined to rebuild what the water has taken. Everywhere you look, the ocean writes variations on the same theme: persistence through change. An octopus slips through a narrow crevice, its skin rippling from one color to another, camouflage born from thought. A cuttlefish flashes patterns of light across its body to communicate with others, messages written in pulses faster than human eyes can follow. Each gesture, each transformation, is a language, a silent conversation between survival and beauty. Even algae, those simple green drifters, perform miracles of motion and growth. Some species of giant kelp can grow more than a meter each day, reaching toward the light with speed that rivals any plant on land. They form underwater forests where fish, seals, and sea otters find shelter. These kelp forests breathe for the planet, absorbing carbon, creating oxygen, and moving like slow waves of life anchored to the seafloor. In the rhythm of these organisms, we find echoes of our own. We too are built to adapt, to renew, to shine even when the world feels dark. Every cell in the human body carries the same quiet instruction found in jellyfish and coral: to survive, to change, to begin again. Perhaps that is why the ocean feels so familiar. It mirrors us, vast yet fragile, old yet ever new. Its creatures may seem alien, but their lessons are intimate: that life is not static, that beauty often comes from necessity, and that light, even in the deepest dark, is never truly lost. So, as you drift deeper into this glowing world, imagine the black water around you, shimmering with slow breathing constellations. Each pulse of light a heartbeat, each flicker a message from the ancient language of evolution. This is not chaos. This is design, elegant, patient, and endlessly alive. And somewhere, in the endless dark, a single jellyfish folds back into youth once more, reminding the world that time itself can be rewritten, if only you learn to flow. Beneath the shining surface, the ocean hides entire mountain ranges, vast ridges that encircle the planet like the veins of the earth. They are unseen by human eyes, yet they shape the world above in ways few imagine. These are the mid-ocean ridges, where continents are born, where fire meets water, and where the earth renews itself in silence. Stretching for more than 65,000 kilometers, the mid-ocean ridge system is the longest mountain chain on Earth. It is longer than all the Andes, the Rockies, and the Himalayas combined. But unlike the mountains we climb, these summits rise in darkness beneath miles of crushing pressure. Here, the planet is still alive. Molten rock rises from the mantle, spreading the seafloor apart at a rate of only a few centimeters each year. Slow, steady, unstoppable. The kind of creation that requires patience beyond comprehension. When magma touches seawater, it cools instantly, hardening into new crust. This is how the ocean floor is born. The ridges form towering peaks and valleys, some tall enough to rival any on land. Their slopes covered not by trees or snow, but by rivers of black rock and drifting plankton. In the darkness, life finds a way even here. Worms, crabs, and blind fish gather near volcanic vents, feeding on minerals that pour from the Earth's heart. This place, though silent, hums with energy. The heat rising from fissures drives ocean currents, and those currents, in turn, shape the climate of the entire planet. Every gust of wind, every rainfall, every season you've ever known begins with this hidden motion beneath the waves. It is the deep breath of the world unseen, yet always felt. Imagine standing on the crest of one of these underwater mountains. There is no sound, only pressure, no sky, only darkness scattered with drifting snow made of organic dust. And yet, around you, the earth is in constant motion, spreading, cracking, breathing through vents that glow like embers at the bottom of the sea. Each pulse of magma, each plume of heat, is a heartbeat of the planet itself. These fiery ridges are not destructive, they are creative. They build new crust, even as old crust sinks elsewhere into the depths, recycled in a continuous loop known as plate tectonics. It is a dance as old as time, one that keeps continents drifting and oceans reshaping their boundaries. Without it, Earth would be a silent sphere, no mountains, no earthquakes, no evolution of landscape. The ridges are the architects of change, their invisible hands sculpting the surface we call home. Somewhere along these ridges, black smokers, towering vents of superheated water rise from the seafloor. They spew mineral-rich plumes into the dark, forming strange chimneys that glisten like obsidian towers. Around them thrive ecosystems unlike any other on Earth. Life sustained not by sunlight, but by chemistry. Bacteria feed on hydrogen sulfide, turning it into energy through a process called chemosynthesis. They are the foundation of deep-sea communities, a living proof that life does not need light, only possibility. It is humbling to realize that entire ecosystems exist in complete darkness, thriving in conditions once thought impossible. These creatures, pale, sightless, enduring, remind us that the definition of life is wider than we can imagine. They flourish beside boiling vents, in waters that could melt metal, where pressure could crush steel and yet still cradle fragile forms of existence. In their persistence lies a quiet truth, that creation and survival are never separate, they are one and the same. The mountains beneath the ocean are more than geological formations. They are the planet's spine, holding everything in balance. They push continents apart and pull others together. They write the story of motion into the very rock beneath our feet. Every tremor you feel on land begins as a whisper here, in the unseen ridges where the world is constantly being born. Even now, as you listen, the seafloor is spreading, inch by inch, year by year, an endless rhythm that never ceases. It is not loud, not violent, but it is absolute. The earth creates through stillness, through pressure, through time. And if you could hear it, truly hear it, it might sound like the slow, deep breathing of a giant asleep beneath the sea. So next time you see the ocean's calm surface, remember that beneath it, continents are moving, mountains are rising, and the world is still being written from fire and salt. We live upon a planet that is not finished, a world in the making, sculpted in silence and lit by molten light, and every wave that touches the shore is a reminder of that ceaseless creation happening far below. If you find yourself drawn to that mystery, to the unseen landscapes beneath our feet, let this curiosity be your compass, because to understand the ocean is to understand the earth itself, alive, restless, and endlessly renewing. What part of the deep ocean fascinates you most? The glowing creatures, the hidden mountains, or the silence that holds them all? Share your thought and drift with us into the next chapter of the deep, where the sunlight still touches the water and colors bloom in slow motion. another world unfolds, one of the most intricate ecosystems on Earth. The coral reefs. They cover less than 1% of the ocean floor, yet they cradle nearly a quarter of all marine life. Every fish that flashes past, every ripple of light on living stone, is part of an ancient symphony of survival and beauty. Coral reefs are not made of rock, but of living creatures, tiny polyps no larger than a grain of rice. Each one builds a limestone skeleton around itself, and together they form vast fortresses of color. Generation after generation, these coral architects construct cathedrals that rise from the seafloor, their walls adorned with the movement of life. Fish weave through the arches. Sea turtles glide above the towers. Even the smallest shrimp finds a place among the coral's quiet labyrinths. In the soft current, it all seems delicate, fragile, but the truth is the opposite. Reefs are monuments to endurance. They have survived shifting continents, rising seas, and storms that could flatten cities. Their secret lies in partnership, a silent alliance between coral and the tiny algae living inside their tissues. These algae, called zooxanthellae, capture sunlight and turn it into energy, feeding the coral that shelters them in return. It is a perfect balance, a dialogue of light and life. Yet even the most perfect balances can break. When water becomes too warm, the algae flee. Without them, corals lose their color, a phenomenon known as bleaching. What remains is a pale skeleton, a fragile ghost of what once thrived. But sometimes, when the water cools and the balance returns, the algae come back. And when they do, the reef breathes again slowly, delicately, as though the ocean itself were remembering how to dream. Across the planet, coral reefs form vast networks, the Caribbean's mosaics of turquoise, the Red Sea's corridors of fire and gold, the Great Barrier Reef stretching over 2,000 kilometers along Australia's coast. It is the largest living structure on Earth, visible even from space. Within it, more than 9,000 species move in harmony, their colors shifting with the light like a living kaleidoscope. This single reef produces oxygen, shelters coastlines, and provides food for millions of people. It is not only a marvel of nature, it is a foundation of life. Among the coral's branches, other forests grow, the kelp forests, vast underwater jungles of golden seaweed swaying in the rhythm of the tide. Here, the water cools, the light softens, and the world turns green. Each strand of kelp can grow more than a meter a day, forming towering canopies where seals play, otters hunt, and fish hide among the shadows. The forest moves as one, a slow, fluid dance choreographed by the ocean's breath. These kelp forests are not just homes, they are engines of balance. Their fronds absorb carbon dioxide and release oxygen, transforming energy from sunlight into sustenance for countless species. They stabilize coastlines, filter the water, and even calm waves before they reach the shore. In their motion, there is both grace and purpose, a reminder that harmony is not stillness, but movement in rhythm with the world. When you drift through a kelp forest, light filters down in green ribbons, and the silence feels alive, a soft pulse echoing through every leaf. You begin to sense how connected everything truly is. The fish that dart through the stems feed the seals that rest above, and the kelp itself depends on the minerals that drift upward from deep volcanic vents. Everything light, salt, current, and life flows in one direction, toward renewal. Scientists call these places blue forests because, like the rainforests on land, they are among the planet's most productive ecosystems. But unlike the trees above, their roots do not cling to soil. They anchor to rock and tide, living halfway between stability and motion. It is this delicate balance that makes them so powerful. They remind us that strength does not always mean stillness, and that survival often begins with the willingness to move with the current instead of against it. Both coral reefs and kelp forests play a quiet but vital role in the planet's health. They absorb carbon, protect coastlines, and nurture more life than we can count. Yet they are vulnerable to heat, pollution, acidification, and time. The ocean builds them patiently, but human activity can erase them in a single generation. And so, in protecting them, we are not simply saving beauty, we are safeguarding the lungs and memory of the sea. If you close your eyes now, you might imagine yourself floating through one of these underwater cities. Sunlight dancing through coral spires, schools of fish moving like shifting clouds of glass, the sound of your breath merging with the heartbeat of the ocean. It feels alive, because it is. Every bubble, every current, every glimmer of light is part of the same vast story. A story that began long before us, and, if we are gentle, will continue long after we are gone. The reefs, the forests, the creatures that call them home, they are not separate from the ocean. They are its memory made visible. They remind us that balance is not static, but continuous creation, an act repeated endlessly in water, in light, and in time. And somewhere, beneath the shifting waves, the coral glows again, a soft heartbeat beneath the blue. Every breath you take carries the quiet labor of the ocean. Though you cannot see it, the sea is the planet's lungs, a vast, living engine that keeps the world in balance. Through unseen chemistry and ancient cycles, it gives us the air we breathe, the climate we depend on, and the rhythm of weather itself. More than half of the oxygen in Earth's atmosphere comes not from trees or forests, but from tiny organisms drifting in the waves, phytoplankton. These microscopic plants float near the ocean's surface, turning sunlight into energy and carbon dioxide into oxygen. In their quiet abundance, they are the true architects of life. Every second, countless trillions of them breathe for the planet, and though each one is invisible, together they sustain all that lives above. It is strange to think that the blueness of the sky, the calm of a summer breeze, and even the air filling your lungs, are all linked to the drifting life of plankton below. They are the smallest beings on Earth, yet they have shaped its atmosphere more profoundly than anything else. Without them, the world would be silent, a planet without breath. But their work does not end there. As phytoplankton capture carbon dioxide through photosynthesis, they lock away a portion of it in their bodies. When they die, many sink to the deep, carrying that carbon down with them, where it can remain trapped for centuries or longer. This process, known as the biological carbon pump, is one of the most powerful regulators of climate on Earth. Through it, the ocean absorbs nearly 30% of all the carbon humans release into the atmosphere. In doing so, it slows the warming of the planet, softening the fever of our age with its silent medicine. Yet there is a cost to this generosity. As the ocean takes in more carbon dioxide, its chemistry changes. The water becomes slightly more acidic, making it harder for shell-building creatures like clams, corals, and tiny plankton to survive. Their calcium carbonate homes begin to dissolve, weakening the very foundation of the food web that sustains so much life. It is a delicate equation the sea gives, but it can also tire. This phenomenon is called ocean acidification, and it reminds us that even the planet's greatest systems have limits. The ocean cannot absorb endlessly. Its balance depends on temperature, current, and time, a harmony we have only begun to understand. And yet, despite these changes, it continues its patient work, turning carbon into life, storms into rhythm, and chaos into breath. The motion of the ocean is not random. It follows a vast, interconnected circulation known as the thermohaline conveyor belt, a slow global current driven by differences in temperature and salinity. Warm, salty water flows northward near the surface, where it cools, becomes dense, and sinks into the deep. This cold water then travels back toward the equator, carrying nutrients and regulating the planet's heat like a great, silent heartbeat. Every part of the climate you experience, the rain on your window, the wind that bends the trees, the calm of one season and the storm of another, is touched by this hidden movement. The ocean does not simply exist beneath the weather, it creates it. It stores 90% of the heat trapped by greenhouse gases, shielding us from changes we would not survive otherwise. The sea is both protector and participant, a vast memory of the planet's temperature written in motion. Even the color of the water tells a story. In some places, it shines turquoise, rich with plankton and nutrients, alive with bloom. In others, it turns deep indigo, a mirror of the empty expanse below. Satellites orbiting high above can see these shifts, tracking where the ocean breathes and where it holds its breath. Each pulse of color reveals how alive the sea truly is, its every shade, a reflection of balance of life created, consumed, and reborn. To study the ocean's chemistry is to study the planet's memory. Trapped within its waters are the records of our atmosphere, the rise and fall of carbon, the whispers of volcanic ages, the signatures of civilizations written in salt and current. Every molecule of seawater has journeyed for centuries, through storms and stillness, collecting the fingerprints of everything that has ever lived or died. And perhaps that is what makes the ocean so human in its own way. It gives without asking, remembers without judgment, and continues to breathe, even as the world above it forgets to listen. If you pause now and take a slow, deliberate breath, know that you are participating in the oldest partnership on Earth, a cycle between ocean and air that began long before the first forests, and will continue long after our voices fade. We often look upward when we think of life towards sunlight, towards stars, but the true foundation of existence lies below, in the quiet rhythm of water and wind. The sea is not separate from the sky, it is its reflection. Every cloud, every gust, every heartbeat of weather begins with the ocean's sigh. So the next time you feel the breeze on your skin, remember that it once passed through the breath of plankton, through the salt of waves and the rhythm of tides. You are breathing the ocean, not metaphorically, but literally. Its breath becomes yours, and yours, in turn, returns to it. In that endless exchange, the world continues. The sea inhales our carbon, exhales our oxygen, and in between those two movements, life finds its balance. This is the quiet choreography of survival, the dance of air and water that makes every moment possible. And perhaps that is the ocean's greatest lesson. That balance is not stillness, but reciprocity, a giving and receiving so constant, so complete, that it feels like peace. The deeper we travel, the quieter the world becomes. Light fades, colors vanish, and the ocean changes from blue to black. We have left behind the familiar warmth of the sunlit shallows and entered a realm where pressure reigns, where time slows, and where life survives on the edge of possibility. This is the deep sea, the largest and least explored habitat on Earth. It begins around 200 meters below the surface, the twilight zone, and continues downward for thousands of meters, into darkness so complete that it feels infinite. Here, the weight of the water above you is crushing. Every square inch of your body would feel the force of several tons. Yet somehow, in this impossible pressure, life endures. At around 1,000 meters, sunlight disappears completely. The temperature drops close to freezing. No human could survive here unaided. Yet the ocean is alive with quiet motion. Jellyfish glowing like paper lanterns, translucent fish with glass-like skin, and delicate creatures that drift as if gravity has forgotten them. Every species here is an answer to a question asked by darkness. How can life exist when there is no light? Some creatures solve it through light of their own, through bioluminescence, They create glowing signals to find mates or confuse predators. Others rely on touch, vibration, or even electrical fields to sense what sight cannot reveal. Their designs are alien, but their logic is perfect, each one shaped precisely by the world it inhabits. The deeper we go, the more extraordinary the landscape becomes. At 3,000 meters lies the abyssal plain, a vast expanse of fine sediment stretching farther than any desert on land. It is among the flattest places on Earth, a silent floor where creatures leave trails that last for years because nothing disturbs them. Small white sea cucumbers crawl slowly across the mud, feeding on falling detritus known as marine snow, tiny fragments of dead plankton, waste, and dust that drift down from the world above. It is the ocean's gentle rain of nutrients, sustaining life where no sunlight has ever reached. Occasionally, the monotony of the plain is broken by mountains rising from the dark, seamounts, peaks taller than Everest, though unseen by any eye. These underwater giants are oases in the abyss, gathering currents that bring food and life to the deep. On their slopes grow forests of coral, not the bright ones of the tropics, but cold water corals that bloom like white lace in the dark. Crabs, shrimp, and fish swirl around them, their movements slow and deliberate, conserving energy in this endless night. And then, far below even that, the ocean floor drops again, into the Hadal zone, where the deepest trenches cut into the planet's crust. The most famous of these is the Mariana Trench, plunging nearly 11 kilometers below the surface, so deep that if Mount Everest were placed inside it, its peak would still be more than a kilometer underwater. At those depths, the pressure is unimaginable, more than 1,000 times what we feel at sea level. Yet even here, in this hostile realm of crushing force, life continues. Tiny amphipods scavenge across the sediment, snails crawl on mineral-rich mud, and microbes feed on chemicals rising from the Earth's crust. Some of these microorganisms can withstand conditions that would destroy any known form of surface life. To them, the deep is not a grave, it is home. When explorers first sent cameras into the trench, they expected emptiness, silence, the end of all motion. Instead, they found vitality, slow, patient, luminous, life that glows faintly in the dark, life that thrives on heat and pressure, life that rewrites what we thought possible. In those moments, the deep sea stopped being a mystery of absence and became a cathedral of endurance. Every descent into this abyss reveals a paradox. The deeper we go into stillness, the more alive the world becomes. Each creature, no matter how strange, is part of a chain that connects surface to seafloor, sunlight to shadow, energy to rest. The deep sea recycles what the upper ocean leaves behind, breaking down waste, absorbing carbon, and breathing balance back into the system. Without it, the surface could not live. And so, the next time you look at the calm horizon, know that beneath it lies not emptiness, but movement, a slow, endless respiration of water, heat, and life. Every ripple above is tied to a current below. Every gust of wind owes its birth to this quiet motion in the dark. The deep ocean is not a void, it is the foundation of the planet, the silent equilibrium that holds everything in place. Perhaps that is why it feels sacred. It humbles the mind and silences the noise of thought. To imagine it is to glimpse eternity, a space where life has learned to exist without comfort, where beauty emerges not in light, but in resilience. The pressure that would crush us sustains them. The darkness that would terrify us shelters them. And in that reversal lies the most profound truth of all, that life, wherever it can exist, always will. The deep ocean is the final frontier, the last unexplored wilderness of our planet, a reminder that mystery still surrounds us, and that even in the age of satellites and algorithms, there are worlds we have barely touched. It asks us to look inward, to listen more deeply, to remember that silence, too, is a kind of intelligence. Down there, beneath 11 kilometers of water, the earth still breathes in slow motion. And if you listen closely, you might hear it. A low, eternal heartbeat echoing from the planet's core. The sound of persistence, the sound of life that refuses to end. In the deepest shadows of the ocean, where sunlight has never reached, something extraordinary happens. Here, far beneath the waves, life exists without the need for the sun, a world powered not by light, but by chemistry. This realm is shaped by hydrothermal vents, underwater geysers that erupt from cracks in the Earth's crust, spewing superheated water rich with minerals into the darkness. The temperature near these vents can reach 400 degrees Celsius, yet the pressure is so immense that the water does not boil. Instead, it surges upward like smoke from the ocean floor, black plumes filled with sulfur, iron, and other elements from deep within the planet. When this scalding water meets the icy cold of the surrounding sea, minerals crystallize, forming towering chimneys of stone and metal. They rise like cathedrals from the abyss, glowing faintly in the light of the submersible lamps. Around these vents, life thrives in abundance. It is not life that feeds on sunlight, but on chemical energy, a process called chemosynthesis. Here, bacteria convert hydrogen sulfide into organic compounds, creating the foundation of an entire ecosystem. These microbes are eaten by worms, clams, shrimp, and crabs, each adapted to withstand the heat, darkness, and toxic gases. It is a community built on what we once thought impossible, life born directly from the chemistry of the Earth itself. When these vents were first discovered in 1977, scientists were astonished. Until then, it was believed that all life depended on sunlight, but the creatures living around hydrothermal vents proved otherwise. They showed that the planet can support life even in total darkness, a revelation that reshaped our understanding of biology and evolution. It also opened the door to a larger question. If life can exist here in the cold, the dark, the extreme, could it not also exist elsewhere? Beneath the frozen oceans of distant worlds, astronomers now study places like Europa, the icy moon of Jupiter, and Enceladus, the bright white moon of Saturn, where vast oceans are thought to lie beneath their frozen crusts. Both worlds may harbor hydrothermal activity, and if so, they might also cradle life not like ours, but life nonetheless. The ocean floor, in its silence, has become a mirror for the cosmos. By exploring these vents, we are not just studying Earth's depths, we are learning how life might begin anywhere the conditions are right. Closer to home, the vents themselves form a network of change. They shape the chemistry of seawater, release vital nutrients, and influence ocean circulation. Even when the vents cool and die, their mineral towers remain, becoming reefs for other creatures, a transition from heat to home. In this way, the cycle continues. Destruction becomes creation, and even in death, the earth builds again. Among the most remarkable inhabitants of these vents are the giant tube worms, pale, ghostly creatures that can grow taller than a human. They have no mouths, no stomachs, no eyes. Instead, they host colonies of chemosynthetic bacteria within their bodies, sharing a perfect symbiosis. The bacteria produce energy, and the worm provides shelter. It is a relationship that embodies the very essence of survival. Two forms of life depending entirely on one another in a world without light. Nearby, colonies of giant clams gleam under the submersible lights, their shells streaked with metallic hues. Translucent shrimp move across the vent chimneys, their bodies almost invisible except for their glowing eyes. It is a scene both alien and intimate, as though the ocean is revealing the blueprint of creation itself. Here, energy flows not from the sky, but from the molten heart of the earth. Every few years, The vents shift and change. New ones open, old ones collapse, and entire ecosystems migrate to follow the warmth. The ocean floor is constantly rewriting itself, a restless map drawn in fire and pressure. And through that endless renewal, the deep remains alive. Scientists have come to call these regions cradles of life. Some believe the first living organisms on Earth may have formed around vents like these billions of years ago, when the oceans were still young and the air was toxic. In that ancient time, chemistry met water and gave birth to biology. It is humbling to think that the same forces still exist today, continuing the same quiet miracle in the hidden corners of the sea. To gaze upon a hydrothermal vent is to see the Earth creating in real time. The minerals that pour from its fissures will one day become rock. The life that gathers there will leave traces in the sediment, and millions of years from now, those traces may tell the story of how our world stayed alive. Everything that lives here, the worms, the shrimp, the microbes, is part of an unbroken chain connecting past, present, and future. In the glow of the vent's rising plumes, you can almost imagine the ocean's first breath, a world awakening from chemistry to consciousness. And perhaps, when we listen closely to the hiss of that superheated water, we are hearing not destruction, but creation repeating itself, a whisper from the planet's beginning, still echoing in the dark. So, as you drift through this world of heat and pressure, remember that the fire beneath your feet is not only a force of destruction, but a source of renewal, a heartbeat deep within the sea. The Earth, even in its depths, is always alive, always breathing, always beginning again. If you've enjoyed this journey into the ocean's secret world, consider subscribing to LUMIVERSE NL. Every week, we dive deeper into science, time, and the quiet miracles of existence. Let curiosity guide you to the next horizon beneath the waves. From the fiery vents of the ocean floor rises a silent current, slow, powerful, and eternal. It moves not like wind or tide, but like the heartbeat of the planet itself. This is the thermohaline circulation, often called the global ocean conveyor belt, a vast system of water that connects every sea on Earth into one living body. It begins in the cold, dark waters near the poles, where frigid temperatures and high salinity make seawater dense enough to sink. This heavy water descends into the abyss, flowing along the seafloor for thousands of miles, before eventually rising again in distant, warmer regions. It is a cycle that takes centuries to complete a slow dance of heat, salt, and motion that never stops. Though invisible, this circulation shapes everything we know. It carries warmth from the equator to the poles, regulates global climate, and nourishes marine ecosystems across continents. Every wave that reaches ashore, every storm that stirs the sky, every breath of wind you feel on your skin is, in some small way, a consequence of this unseen engine turning beneath the sea. Imagine the ocean as a single vast organism, its circulation, the bloodstream that keeps it alive. Nutrients from the depths rise to the surface, feeding plankton and fish. Heat from the tropics travels northward, keeping regions like Western Europe warm enough for forests and rain. Without this global conveyor, the Earth's weather would fracture into chaos. Tropical heat trapped at the equator, polar ice spreading outward in silence. The balance we live within is a gift of this continuous flow. To visualize it is to imagine rivers moving within the ocean itself. The Gulf Stream, for instance, begins in the Caribbean and flows north along the Atlantic coast. It carries vast amounts of heat, as much energy as 1 million power plants, across the ocean, reaching as far as Norway and the Arctic Circle. Because of it, cities like London and Amsterdam are temperate, while others at the same latitude, like Calgary or Moscow, endure harsh winters. This single current has shaped civilizations, migration patterns, and entire ecosystems, and yet it moves in silence, unseen beneath the surface. Farther south, similar systems stir the Indian and Pacific Oceans. Cold waters from the Antarctic creep northward, carrying oxygen and dissolved minerals into deep basins where life thrives even in darkness. When these waters finally rise again through a process called upwelling, they bring with them nutrients that feed the ocean's surface life. These nutrient-rich zones, off the coasts of Peru, Namibia, and California, become havens for plankton blooms, fish populations, and seabirds in their millions. Upwelling is the ocean's act of renewal, the return of what has sunk, the deep giving back to the light. But this delicate system depends on stability. Changes in temperature or salinity can slow or even stop the flow. If polar ice melts too quickly, the sudden influx of fresh water can dilute the saltiness that drives the sinking process. The engine weakens, the planet's natural conveyor begins to falter, and with it comes a ripple through the climate storms growing stronger, currents shifting, rainfall patterns collapsing. The ocean's circulation is like a whisper, easily broken, yet vital beyond measure. Still, even in its fragility, there is elegance. The thermohaline system is not a single current, but a web, a tapestry of motion connecting all the world's oceans into one great breath. It binds the Arctic to the equator, the Pacific to the Atlantic, the surface to the deep. When one part slows, another compensates. When the planet warms, the ocean absorbs and redistributes the change. It is the ultimate act of balance, dynamic, living, responsive, and it is not just physics. This circulation carries stories. Dust from deserts that nourish coral reefs, volcanic minerals that feed plankton blooms, and even microscopic seeds of life traveling between hemispheres. Every current is a messenger, every wave a conversation between distant parts of the earth. To study the sea is to listen to that dialogue, to recognize how every motion, no matter how slow, eventually reaches everywhere. If you could trace a single drop of water from the North Atlantic, you would watch it sink beneath icy waves, drift south along the ocean floor past Africa, circle Antarctica in the cold abyss, then slowly rise again in the Indian Ocean centuries later, transformed, renewed, carrying the memory of its journey. In that drop lies the story of the planet's endurance. The ocean's circulation is not constant speed, but constant rhythm. It breathes in patterns of centuries, a scale of time larger than humanity itself. Our lifetimes are single heartbeats in the ocean's pulse. And yet, in that vastness, there is connection. The warmth you feel on a spring afternoon may have begun its journey from a current moving unseen beneath Antarctic ice, long before you were born. Every current, every eddy, every swirl of the tide is part of a single organism, a planet alive and self-regulating, always adjusting, always flowing. And though we cannot hear it, the sea continues to speak through motion, reminding us that balance is not achieved through stillness, but through movement. Next time you watch the horizon, imagine the slow, invisible rivers beneath, streams of warmth and salt, of life and memory, connecting every corner of the earth in quiet synchronization. This is the ocean's secret order, its invisible symmetry, the heartbeat beneath the waves. And as long as it flows, the planet will continue to breathe. The ocean, though vast and silent, is never still. It moves in rhythm, a slow, endless choreography of waves, tides, and hidden energies. If the deep circulation is the planet's heartbeat, then the waves and tides are its breath, inhaling and exhaling across the surface of the world. Every ripple begins with a whisper, the touch of wind upon water. A breeze becomes a rhythm becomes a swell, and soon the surface rolls with motion that can travel thousands of miles. These waves carry not water itself, but energy, a pulse passed from one molecule to another, moving through the sea like a thought drifting through a dream. When they finally reach the shore, they surrender their energy to sand and stone, shaping coastlines, carving cliffs, and building beaches grain by grain. It is sculpting through patience the artistry of time. Waves can cross entire oceans without losing their strength. A storm in the Pacific may send swells to the coasts of South America weeks later, its power undiminished, its rhythm unchanged. Surfers in Hawaii may glide across energy, born from winds thousands of kilometers away. This is the ocean's long-distance language, a conversation between continents carried by motion and silence. But not all waves are gentle. Some are born from violence, earthquakes, volcanic eruptions, or underwater landslides. These are the tsunamis, waves of unimaginable scale. Unlike wind-driven waves, which only move the surface, a tsunami moves the entire column of water from seafloor to surface, carrying energy across oceans at the speed of a jet plane. When it reaches shallow water, that energy compresses, rising into towering walls that can reshape coastlines in moments. They are reminders that beauty and power are often two sides of the same tide. Yet even the smallest wave holds meaning. The rhythmic lapping of the sea against rock, the gentle pull of water returning to itself, has guided human hearts for as long as we have listened. Poets have written of it, musicians have imitated its cadence, and sailors have trusted its patterns to cross the unknown. To live near the ocean is to live beside eternity in motion. And then there are the tides, the grand, predictable breathing of the sea. They rise and fall not by chance, but by gravity's pull, drawn by the moon and to a lesser degree, the sun. As the moon circles Earth, its gravity pulls the water toward it, creating a bulge, the high tide. On the opposite side of the planet, another bulge forms, the ocean stretching outward like a heartbeat, responding to the sky. Between them, the water falls away into low tide. This slow pulse governs the rhythm of countless lives. Crabs scuttle across exposed sand during low tide to feed. Seaweeds bend and sway, then rise again as the water returns. Corals spawn in harmony with lunar cycles, timing their reproduction to the light of the full moon. Entire ecosystems live by the clockwork of tides, a celestial rhythm translated into life. For humans, tides have always been teachers. Fishermen learned to read them long before modern science could describe them. Ancient civilizations built calendars from their patterns, marking months and festivals by the sea's rise and retreat. Even now, coastal communities plan their days by the same rhythm, proof that, despite our technologies and cities, we still live by the ocean's schedule. The energy of tides is not only poetic but physical. Scientists have begun to harness it, turning tidal motion into electricity. Massive underwater turbines now spin with the rise and fall of the sea, converting gravity's ancient pull into power for human use. This is known as tidal energy, one of the most promising forms of renewable power. It is clean, predictable, and infinite, a partnership between nature's rhythm and human ingenuity. There is another form of power hidden in the ocean's motion: wave energy. By capturing the up and down movement of surface swells, engineers can generate electricity without smoke or fuel. Across test sites in Scotland, Japan, and Australia, floating machines rise and fall with the waves, their movement converted into light that glows in homes miles inland. It is as if the sea itself is learning to speak in voltage, its timeless rhythm turned into something modern, something shared. Still, for all our efforts to harness its motion, the ocean remains sovereign, untamed, and patient. Its power is steady but unpredictable, its moods shifting with weather, moon, and season. It reminds us that energy, like life, flows best when respected, not controlled. When you stand at the edge of the sea and watch the water move, you are witnessing the oldest story in motion, the conversation between earth, moon, and sun, the endless trade of energy that began before humanity existed. Every wave that rises is a memory, every tide that falls, a renewal. And perhaps, within that ceaseless motion, there is a kind of wisdom, a lesson written in salt and rhythm. The waves do not resist the wind. They carry it. The tide does not fight gravity. It yields to it. Yet, in that yielding lies immense power. Maybe that is what the ocean teaches best, that surrender is not weakness, but the recognition of rhythm greater than ourselves. So, as you listen to the ocean tonight, the crash of surf, the whisper of foam on the sand, remember that it is not merely sound. It is the voice of the planet breathing, the music of motion, the heartbeat of tides, the endless conversation between water and sky. In every ripple lies the echo of creation, and in every wave, the promise that movement, not stillness, is the path to harmony. Not all intelligence speaks in words or thoughts. Some of it moves silently beneath the waves in gestures, in memory, in instinct refined over millions of years. The ocean is filled with minds that do not resemble our own, creatures that feel, communicate, and solve problems in ways that blur the boundary between animal and awareness. Among the most extraordinary are the octopus and its kin, the cephalopods, squid, and cuttlefish, beings of liquid grace and color, built not from bone but from adaptability itself. An octopus can taste with its skin, see with polarized vision, and control each arm independently, as if it were its own mind. 2/3 of its neurons live in those arms, allowing it to think through touch, to explore the world like a painter, feeling texture instead of seeing it. When an octopus slips through a crack no wider than its eye, it is performing an act of pure intelligence, not brute strength, but precise calculation, a knowledge of shape and self. It remembers the location of objects, unscrews jars to reach food, and even plays tossing shells and rocks for no reason other than curiosity. In captivity, some octopuses have learned to recognize individual humans, squirting water at those they dislike, and gently wrapping their arms around those they trust. It is impossible not to feel that something in those eyes is watching you back. The cuttlefish, too, is a master of subtlety. Its skin can change color, pattern, and texture in less than a second. An organic screen capable of millions of combinations. Through this living canvas, it communicates with others of its kind, sending signals that ripple like coded messages across its body. Some patterns say, "I am hunting." Others mean, "I am ready to mate." To the untrained eye, it is pure art. But to them, it is language, a syntax of light. Then there are the dolphins, the ocean's eternal students. They live in pods, families bound by sound. Their communication is complex, a system of clicks, whistles, and pulses that function like names, each dolphin identifying itself with a unique signature whistle. They use echolocation to paint the world in sound, bouncing clicks off the environment to see without sight. With this sonar, they can detect not only shapes, but textures, movements, even the heartbeat of another creature. Dolphins cooperate when hunting, taking turns herding schools of fish into tight circles, then diving in perfect unison to feed. They care for the sick, mourn their dead, and sometimes, for reasons we still don't understand, have been known to protect humans from sharks or guide lost swimmers toward shore. Whether we call it empathy or instinct, it reveals something profound, that intelligence is not defined by language, but by connection. Even smaller creatures show flashes of brilliance. Sea otters use rocks as tools, cracking open shellfish on their bellies as they float. They pass this skill down to their pups, teaching by example a cultural inheritance not unlike our own. In coral reefs, cleaner wrasses set up stations where larger fish line up to have parasites removed. They remember their clients, adjust their behavior based on who waits longest, and even cheat, taking small bites of mucus when they think no one is watching. It is commerce in miniature, a quiet reminder that intelligence wears many forms. And then there are the whales, giants of memory and song. The humpback whale sings patterns that can last for hours, intricate melodies that change over time, spreading across oceans as if carried by the planet's own voice. Each population has its own dialect, its own evolving culture of sound. The sperm whale, with the largest brain of any creature on Earth, communicates in rhythmic clicks known as codas, each clan with its unique acoustic signature, passed through generations like lineage. For whales, sound is more than communication. It is existence itself. In the lightless depths, their songs become maps, stories, and memories. Through them, we glimpse an ancient continuity, a way of living that measures time not in years, but in migrations across hemispheres. To listen to a whale song is to feel the earth breathing at a lower frequency, a slow, resonant hum that travels farther than any human sound can reach. It is said that a blue whale's call, deep and trembling, can be heard hundreds of miles away, and that every note carries both loneliness and connection, a reminder that the ocean, for all its distance, is full of voices seeking one another. When scientists record these songs, they are not just studying patterns, they are eavesdropping on an intelligence older than our own. Some of these sounds repeat across generations, others evolve like traditions, proof that even in the great silence of the deep, culture thrives. If you could see the ocean from above, you might imagine it as a vast web of signals, a living network of sound, touch, and light. Every creature, from the smallest shrimp to the largest whale, participates in that dialogue. We are only beginning to understand the grammar of the sea, and perhaps we never will. But the more we listen, the more we realize that intelligence is not the exception. It is the rule. The ocean is not simply filled with life. It is filled with awareness, a chorus of minds tuned to the frequencies of survival, adaptation, and wonder. Each pulse, each flicker, each echo in the water is a thought wordless, yet meaningful. And in that realization, a quiet humility emerges. Perhaps the question was never, are we alone in intelligence? But rather, can we still remember how to listen? For when we do, we will find that beneath the surface, the sea is speaking, and has been, all along. In every ocean, from the warm coral shallows to the frozen polar seas, one presence moves with silent confidence. The shark, it is both feared and revered, a creature that has survived for more than 400 million years. Long before trees rose from the land or birds took to the air, sharks ruled the sea. They are older than the mountains, older than the continents themselves, an ancient lineage of motion perfected by evolution. To watch a shark swim is to witness precision. It wastes nothing. Every flick of its tail, every turn of its body, is balanced between power and grace. It does not chase chaos. It follows rhythm. It has no need for hurry, because time has always been on its side. Beneath its streamlined form lies a biology sculpted by survival. Its skin is covered in tiny, tooth-like scales called dermal denticles, which reduce drag and allow it to glide silently through the water. Its muscles are built for endurance, fueled by a heart that can travel across entire oceans without rest. Its senses, though invisible, extend far beyond ours, a living symphony of perception tuned to the faintest signals of life. Among those senses, one stands out as almost supernatural: electroreception. Along the shark's snout lie small, jelly-filled pores called the ampullae of Lorenzini. Through them, the shark can detect the weak electrical fields generated by every living thing, the beating heart of a fish hidden beneath sand, the pulse of movement in murky water, even the metallic hum of Earth's magnetic field itself. To a shark, the ocean is alive with invisible light. It does not see the world as we do, through color and shape, but through energy, the language of existence itself. Because of this gift, sharks can hunt with uncanny accuracy, even in darkness. They can sense a fish's heartbeat meters away, feel the vibration of a wounded animal carried through the current, and navigate vast distances by following the planet's magnetic lines. They are living compasses, travelers of a silent map written in salt and pulse. Yet for all their power, sharks are not mindless predators. Their behavior is careful, often curious, sometimes almost gentle. Divers who have spent years studying them describe moments of quiet recognition, a shark circling not in hunger but in observation, testing, learning, remembering. Some species, like the lemon shark, can recognize individuals of their kind and maintain complex social hierarchies. Others, such as the great white, migrate thousands of kilometers with astonishing precision, returning year after year to the same feeding grounds, the same breeding sites. In that repetition lies memory, the inheritance of instinct passed across generations. But even the apex of evolution can be fragile. Many shark species reproduce slowly. Some take more than a decade to reach maturity, and females give birth to only a few pups at a time. This delicate cycle makes them vulnerable to overfishing and environmental change. The oceans that once echoed with their presence now grow quieter. Populations decline, food webs shift, and ecosystems lose the balance sharks once kept in place. It is easy to fear what we don't understand. For centuries, humans have seen sharks as monsters, symbols of danger rising from below. But to the ocean, the shark is balance itself. Without them, the strong go unchecked, the weak disappear, and diversity collapses. They are the regulators of abundance, keeping coral reefs and open waters alike in harmony. Their existence is not a threat, it is a necessity. Consider the hammerhead, its head spread wide like a compass of evolution. Those strange, wing-like extensions hold sensory organs that allow it to scan vast areas of sea at once, detecting prey invisible to other species. Its shape may look alien, but it is a masterpiece of function, each curve designed by the mathematics of water. Or the whale shark, the gentle giant, the largest fish on Earth, stretching over 12 meters long, yet feeding only on plankton. It moves slowly, mouth open to filter millions of tiny organisms with each pass. A creature of immense size and perfect calm, divers often describe the experience of swimming beside one as humbling, as if the sea itself had taken form to remind us of its scale. And then there is the tiger shark, known for its broad diet and adaptability, a scavenger, a cleaner, a survivor. It consumes what others leave behind, transforming waste into nourishment and maintaining the ocean's silent recycling system. In its hunger lies balance. In its endurance, a story of resilience. Each shark is a reflection of the ocean's nature, efficient, patient, balanced. They embody the calm power that defines the sea itself, neither cruel nor kind, simply true to its design. In their movements, we see the wisdom of purpose without excess, strength without rage, and life without vanity. If you listen to the water around a shark, there is no roar, no disturbance, only the whisper of motion. It is this quietness that keeps it unseen until the last moment, not out of malice, but mastery. The shark is not the villain of the sea, it is its oldest guardian, When you look at its dark eye, you are not staring into danger, but into a mirror of evolution, a consciousness shaped by patience, a being that has learned to survive not by domination, but by design. The ocean does not waste, neither does the shark. Every movement is earned, every decision precise. Perhaps that is why they inspire such awe, not because they represent fear, but because they represent control, balance, and endurance in a world defined by change. So the next time you imagine the deep, think not of sharp teeth or shadows circling in silence, but of motion perfected through time, a shape sculpted by the same forces that built the tides. The shark is the ocean's memory of what survival truly means. And if you stand by the shore, feeling the waves pull at your feet, remember that somewhere beyond the horizon, a shark glides through the water, ancient, unhurried, a reminder that life endures not through fear, but through equilibrium. Which ocean creature fascinates you most, the gentle whale shark, the precise hammerhead, or the quiet power of the great white? Share your thoughts, and continue with us as the story of the deep unfolds further into its mysteries. In the endless expanse of the ocean, where pressure crushes and darkness reigns, one law persists above all others, the law of survival through renewal. Life in the sea does not simply endure, it regenerates, rebuilding itself in quiet defiance of time. Nowhere is this more evident than in the remarkable creatures who can restore what has been lost, beings that blur the line between survival and rebirth. Consider the sea star, often called the starfish, delicate in appearance, yet astonishingly resilient. When one of its arms is severed, it does not die. Instead, the wound begins to heal. Cells gather at the edge, and slowly, over months or years, an entirely new limb begins to grow. If even a fragment of its central disc remains, that piece alone can regenerate into a whole new creature. It is as though each part of the sea star carries the blueprint of the entire being, a living symbol of the ocean's capacity to rebuild itself from loss. To scientists, this process is more than a marvel. It is a message. Regeneration is not magic, it is biology's quiet perfection. Within the sea, stars' tissues are specialized cells that can transform into any type of body part needed, a universal potential encoded into every fragment. When damage occurs, these cells awaken, migrate, and reconstruct what has been taken. The result is not a scar, but restoration. In a world that knows only erosion and decay, regeneration is the ocean's most powerful form of resistance. The ocean is filled with such miracles. The sea cucumber, though humble in form, can liquefy its body to escape predators, squeezing through impossibly narrow crevices before re-solidifying moments later. When threatened, some eject their internal organs entirely, sacrificing themselves to distract the attacker, and then, astonishingly, grow them back over time. Even destruction becomes a strategy for survival. The sponges, some of the oldest multicellular organisms on Earth, possess an ability that defies imagination. When cut into pieces, their cells can drift apart, then recognize one another again and reassemble into a new sponge. No central brain, no command, only memory written in structure. They are the quiet engineers of the reef, filtering water, recycling nutrients, and reminding us that intelligence can exist in organization itself. Deeper still, in the black waters where light cannot reach, life continues to prove its endurance. Microbes thrive near volcanic vents, repairing their DNA after doses of radiation that would kill any surface life. Some fish and worms can regrow organs lost to predators, and tiny jelly-like creatures known as salps replicate themselves endlessly, forming vast chains that drift through the deep like living ribbons of light. The ocean is not just alive, it is constantly recreating itself, This cycle of renewal mirrors the planet itself. Coral reefs bleach and die, only to recover when the waters cool. Kelp forests are torn by storms, yet sprout again from hidden roots on the seafloor. Even the tides participate in this endless rhythm, retreating, returning, and rebuilding with every pull of the moon. In the sea, nothing is ever truly still, and nothing is ever truly lost. Perhaps that is the secret of the ocean's calm. What appears tranquil on the surface is, in truth, perpetual change, a balance between death and rebirth, creation and decay. The sea does not fear destruction because it understands renewal. It teaches us that endings are only transformations disguised as silence. Humanity, too, owes its resilience to this same principle. Our cells heal, our skin renews, our minds adapt. We are reflections of the same regenerative code that pulses through the ocean. We lose, we rebuild, we change form, and through it all, something essential remains: the will to continue. Perhaps we inherited this rhythm from the sea itself, our oldest ancestor and our constant teacher. In the delicate architecture of a coral branch regrowing, in a sponge reassembling itself from scattered fragments, in the slow return of an arm to a patient sea star, we glimpse the quiet genius of life, refusing to surrender. The ocean never stops remaking itself, and in doing so, it renews the world above. If we look closely enough, even the shoreline tells the same story. Every wave that erases a footprint writes a new one moments later. Every grain of sand carried away by the tide will one day return as part of another beach. Renewal is not an act of will. It is the nature of being. It is said that the ocean forgets nothing, but perhaps it doesn't need to, because forgetting is unnecessary when you can begin again. The sea does not cling to what it loses. It lets go and rebuilds in motion, in rhythm, in time. There is no tragedy in that, only continuity. So the next time you think of the deep, imagine it not as a place of stillness, but as a living system, breathing in cycles of renewal. Every cell, every current, every creature participates in the same ancient conversation, that life, no matter how fragile, always finds a way to start again. Somewhere, far beneath the waves, a sea star stirs, its missing limb beginning to form once more. In that quiet process, unseen by any eye, the ocean writes its oldest truth, that endurance is not about strength, but about the courage to grow again after loss. The ocean is not only a place of motion and life, it is also a vast laboratory of chemistry, where every drop of water tells a story of balance. Within its depths, salt and mineral, carbon and oxygen, acid and base are woven together into the invisible web that sustains all existence. The sea is the planet's great alchemist, transforming elements into energy and energy into life. To the untrained eye, seawater may seem simple, clear, blue, eternal. But within a single liter of it lies an entire universe of complexity. Magnesium, calcium, potassium, iron, nitrogen, and traces of gold, all dissolved in precise proportions. These minerals are the fingerprints of the planet's past. They come from volcanic eruptions, eroded mountains, and the ancient bones of creatures long turned to dust. Every wave carries the memory of both creation and decay. Over millions of years, rain has fallen on rock. Rivers have carved through soil, and the minerals released by that slow erosion have flowed back into the sea. Each drop of rain that falls into an ocean carries a fragment of the continents it left behind. This is how the ocean became salty, not through sudden change, but through the slow patience of time. Volcanic vents beneath the seafloor add to this chemistry, pouring metals and gases into the water, while evaporation removes pure water but leaves the salts behind. It is a cycle that has been repeating for billions of years, the ocean breathing in minerals, exhaling balance. Yet the salt we taste in seawater is more than flavor, it is structure. Salinity shapes the density of water, and density drives the global circulation that moves heat, oxygen, and nutrients around the world. Without salt, the ocean would be static. Without motion, the planet would suffocate. The taste of the sea, sharp and elemental, is the flavor of equilibrium itself. But in recent centuries, this balance has begun to shift. As human activity releases increasing amounts of carbon dioxide, the ocean absorbs much of it, nearly a third of all emissions. In doing so, it protects the atmosphere but changes itself. When carbon dioxide dissolves in seawater, it reacts to form carbonic acid, which slowly lowers the ocean's pH. This process, known as ocean acidification, has already altered the chemistry of the seas more quickly than at any time in the last 50 million years. The change is small, just a fraction of a pH point, but its effects ripple through everything alive. Coral reefs, shellfish, and microscopic plankton all rely on calcium carbonate to build their skeletons and shells. As acidity rises, that calcium dissolves more easily, making it harder for new shells to form and old ones to endure. Reefs weaken, shells thin, and the delicate architecture of marine life begins to erode. The damage is quiet but profound, a slow unraveling of one of the planet's oldest systems. In the colder waters of the north and south, the changes are even sharper. Cold water absorbs more carbon dioxide, and so polar seas are the first to feel the shift. Tiny creatures like pteropods, often called sea butterflies, find their translucent shells dissolving faster than they can rebuild. They are small, fragile, almost invisible, but they are also the foundation of the marine food web. When they vanish, entire ecosystems tremble. And yet, even within this struggle, the ocean continues its work. It stores carbon deep within its layers, locking it away for centuries, a quiet act of protection that stabilizes the planet's climate. It absorbs heat, preventing the surface from burning. It generates clouds through evaporation, feeding rain back to the land. The ocean is both shield and sufferer, bearing the weight of what we release, while still keeping the world alive. Its resilience is extraordinary, but resilience has limits. The chemistry of the sea cannot be rewritten without consequence. Every molecule of carbon absorbed changes the equation of life ever so slightly, a whisper of imbalance carried through the food chain, from plankton to predator to us. Because we, too, are part of that chemistry. Our breath, our bones, our blood all carry the same minerals once dissolved in the sea. When the ocean shifts, we shift with it. Still, the story is not one of despair, but of connection. Understanding the ocean's chemistry means understanding our own impact and our potential to heal. By reducing carbon emissions, restoring coastal ecosystems, and protecting wetlands, we can help the ocean restore its natural balance. Seagrass meadows, mangrove forests, and coral reefs act as living filters, drawing carbon from the air and storing it safely beneath the waves. Nature already holds the blueprint for recovery. We need only give it time and respect. The chemistry of the ocean is the chemistry of life. It is delicate but dynamic, vulnerable yet self-correcting when given the chance. Every drop of seawater is a reminder that balance is not static. It must be maintained, renewed, and honored. When you next stand at the shore and taste the salt on your lips, remember what it truly is. Not just water, but history, the memory of rain, the dust of stars, the breath of the planet condensed into a single drop. The ocean holds the record of every age the earth has known, and it continues to write that story with each wave. Our role is not to dominate that story, but to learn its language, to listen to what chemistry tells us in silence. Because when the ocean speaks through its changing tides and shifting pH, it is not crying out. It is reminding us that balance is sacred, and that to preserve life, we must first understand the sea's most fundamental truth. Everything that flows returns, and everything we give to the water will one day come back to us. If the ocean is the planet's breath, then its plants are the lungs that make that breath possible. Beneath the surface, where sunlight filters through blue and gold, a silent forest stretches across the seabed, not made of trees, but of marine plants and algae that sustain life for the entire planet. They are the ocean's green heart, converting light into energy, carbon into oxygen, and stillness into motion. Though we often think of plants as belonging to the land, most of Earth's photosynthesis, the process that turns sunlight into life, happens in the sea. Tiny phytoplankton, drifting in the upper layers of water, perform more than half of the planet's total oxygen production. Every second breath you take, every flame that burns, every cloud that drifts, all of them exist because of these invisible gardens in motion. Yet not all ocean plants are microscopic. Beneath shallow coastlines, seagrass meadows ripple with the tide, their long blades waving like ribbons in slow motion. They may seem ordinary, but they are among the most powerful ecosystems on Earth. Each square meter of seagrass can store up to 30 times more carbon than the same area of rainforest. Scientists call this stored carbon blue carbon, a name that captures the essence of the sea's hidden contribution to climate balance. Seagrasses do more than capture carbon. Their roots bind the sand, protecting shorelines from erosion and calming the force of storms. They provide nurseries for young fish, shelters for seahorses, and resting places for sea turtles. In their gentle swaying, you can see the choreography of resilience, life bending but never breaking, to the rhythm of the tide. Nearby, in the tangled waterways where land meets the sea, another guardian stands watch the mangrove forest. With roots that rise from the water like ancient sculptures, mangroves thrive where few others can survive. In salty, oxygen-poor mud where tides rise and fall twice each day, their roots filter salt from seawater, their branches host birds, insects, and crabs, and their tangled trunks trap sediment and nutrients that would otherwise drift away. They are both fortress and cradle, protecting coastlines from waves while nurturing life within. Mangroves are masters of adaptation. They breathe through specialized roots called pneumatophores, tiny spires that poke above the water to draw in air when the soil below is suffocating. This extraordinary system allows them to survive flooding, salinity, and shifting tides, conditions that would destroy most plants. In their patience lies an ancient wisdom, survival through flexibility, strength through surrender. Together, mangroves, seagrasses, and salt marshes form the ocean's coastal trilogy, ecosystems that sustain life not just in water, but on land. They capture vast amounts of carbon dioxide, filter pollution, and serve as nurseries for nearly 70% of the fish species humans depend on. They are the planet's borderlands, where oxygen is born, where tides breathe, where new life begins. And yet, these blue forests are disappearing faster than tropical rainforests. Pollution, dredging, coastal development, and rising seas have destroyed more than a third of them in the past century. Every hectare lost releases stored carbon back into the atmosphere, accelerating the very warming they once helped to slow. It is a quiet crisis, invisible from the surface, but felt in every storm, every coral bleaching, every disrupted current. Still, the ocean remembers how to heal. Where mangroves are replanted, fish return within months. Where seagrass beds are restored, the water clears, turtles feed, and oxygen levels rise. Nature, when given even the smallest chance, rebuilds with astonishing speed. The same patience that allowed it to evolve over eons still beats within its roots and leaves today. Even the vast kelp forests, the giants of marine vegetation, follow this rhythm of destruction and renewal. Storms tear them from their anchors, but each broken fragment becomes a seed for new growth. Their holdfasts grip rock with the tenacity of life itself, creating underwater canopies that sway like cathedrals of light. Otters wrap themselves in their leaves to rest, fish dart through their golden corridors, and the entire ecosystem moves in unison, a single breathing organism beneath the waves. In these forests, the ocean practices its oldest art: transformation. Carbon becomes oxygen, decay becomes food, stillness becomes rhythm. It is a choreography older than language, the dance of molecules into meaning, the alchemy that keeps the planet alive. When we protect these underwater forests, we are not only conserving beauty, we are defending the mechanisms that sustain all life. The filters, the lungs, the memory of balance. We are safeguarding the ocean's ability to breathe for us. If you close your eyes and imagine descending through clear, shallow water, you might see it. A meadow of seagrass, undulating with the current, sunlight turning every blade into a strand of liquid gold, small fish flickering between the shadows. The water hums with quiet life, a gentle, constant song of photosynthesis, of air becoming breath, of light becoming home. That is the true miracle of the ocean's plants. They do not roar or bloom in brilliance. They simply persist patient, silent, essential. Every leaf beneath the sea is an act of devotion, a prayer written in green to remind us that life endures through balance. And somewhere beneath the waves, the first spark of sunlight touches a drifting plankton cell. It awakens, divides, and begins again. A microscopic garden growing quietly in the endless blue. From that single act of creation, the planet takes another breath. At the far edges of the world, where the sea turns to ice and the horizon blurs into white silence, the ocean takes on a new form, solid, gleaming, and eternal. This is the polar realm, where water becomes sculpture and the heartbeat of the planet slows to a rhythm of frost and wind. Here, life endures at the boundary between freezing and flow, and the ocean's chemistry shapes the destiny of the entire Earth. The polar oceans, the Arctic in the north and the Antarctic in the south, are among the most fragile and vital ecosystems on the planet. Though they cover only a fraction of the Earth's surface, they control much of its climate, reflect its sunlight, and guard its balance. The vast sheets of ice that crown the poles act as the planet's mirrors, bouncing solar energy back into space and keeping global temperatures stable. When that ice melts, the mirror fades and the planet begins to warm faster. Beneath the frozen ceiling, however, life thrives in forms that defy expectation. Tiny algae live within the ice itself, trapped between crystals, glowing faintly green when sunlight filters through. Bacteria and plankton drift below, feeding fish that shimmer like silver ghosts. Seals rest on ice floes, penguins dive in perfect arcs, and in the depths, enormous shadows move with soundless grace, the wails of the cold. This world, though remote, is pulsing with life, its rhythm slower, more deliberate, but no less alive than the tropics. The polar seas are engines of circulation, where cold, dense water sinks to the abyss and drives the thermohaline conveyor that connects all oceans. They are the beginning and the end of the ocean's breath, the exhale of melting ice, the inhale of deep salt currents. Every tide on Earth owes its rhythm, in part, to the slow pulse of the poles. But this balance is changing. In recent decades, the Arctic has warmed more than 4 times faster than the global average. Summer sea ice shrinks earlier, returns later, and vast regions that were once white now glimmer dark blue under the sun. The loss of ice does more than reshape landscapes, it reshapes physics. Without its reflective surface, more sunlight is absorbed by the ocean, accelerating warming in a feedback loop that intensifies with each season. The sea's chemistry changes, currents shift, weather patterns wobble, and what begins in the Arctic does not stay there. Meltwater from Greenland and Antarctica flows into the oceans, altering salinity and density, disrupting the great conveyor belt that distributes heat around the world. This hidden change in rhythm can transform weather thousands of miles away. Droughts, storms, and floods, all whispering of imbalance born in the frozen north and south. The poles are not isolated. They are the ocean's foundation stones. When they tremble, the planet feels the echo. Yet even as the ice retreats, life adapts. New species move northward as waters warm plankton, fish, even whales following the changing currents. In the Antarctic, penguins shift their colonies to new coasts, and seals find hunting grounds beneath thinner ice. The transformation is rapid, but the ocean's inhabitants have always known how to evolve. They live by the same rule the sea itself follows: endure by changing, survive by moving. Still, some losses cut deep. Entire ecosystems depend on ice, from krill feeding on algae beneath its underside to polar bears hunting seals above it. When the ice goes, the balance collapses. Krill populations decline, whales travel farther to feed, and bears wait longer between meals. The chain that connects light to life begins to fray. It is not the cold that threatens the poles now, but the warmth. Scientists studying the Arctic call it the planet's early warning system. What happens there foretells what will come elsewhere. Melting glaciers raising sea levels, thawing permafrost releasing ancient carbon, and changing currents, rewriting the weather for billions of people. The ocean, through its frozen edges, is speaking to us in the language of cause and effect. If we listen carefully, we can still answer. Because even here, among the glaciers and midnight suns, the power of renewal remains. Sea ice lost in summer can return in winter. Protected marine zones allow ecosystems time to recover. And the cold, though shrinking, still breathes. In every drop of meltwater, there is the potential for rebirth, for the ocean to reclaim balance if given the chance. The ice, too, holds memory. Within each frozen layer lie bubbles of air from centuries past, tiny archives of the planet's ancient atmosphere. Scientists drill deep into glaciers to read those records, tracing how Earth's chemistry has changed, how the rhythm of carbon and oxygen has risen and fallen with time. Each layer is a diary of sunlight, a record of breath, a history written in frost. If the ocean is a mirror of the planet's life, then the poles are its conscience, a reflection of how harmony must be maintained through stillness. Here, even silence speaks. The crack of a glacier splitting, the drip of melting ice, the call of a lone seal across the white expanse. All are reminders that the balance between warmth and cold, between motion and rest, is the balance that sustains us all. When you picture the Arctic, imagine not just the frozen sea, but the flow beneath it. Currents that travel the length of the planet, linking every ocean, every coastline, every storm. The ice is not absence. It is energy paused, waiting for the right season to move again. And though the poles may seem distant, their breath is the same breath that fills your lungs. Their melting is your climate shifting. Their silence is your reflection. The world's balance begins and ends in these frozen oceans, fragile, radiant, eternal in their importance. Listen closely to that stillness, because in the quiet heartbeat of the ice, the earth is speaking, not in fear, but in truth. And that truth, like the tide, always returns. The ocean is vast enough to hide its scars, but not to escape them. Beneath the calm surface, a quiet crisis unfolds, a story of pollution, plastic, and imbalance that stretches across every sea. For centuries, humanity has treated the ocean as infinite, a place where all things lost simply disappear. But nothing in nature truly vanishes. The ocean remembers everything. Each year, Millions of tons of plastic enter the sea bottles, bags, fibers, fragments. Carried by rivers, wind, and rain, they drift into open water, breaking into smaller and smaller pieces until they become microplastics, particles no larger than a grain of sand, yet found everywhere from the surface to the deepest trenches. They swirl in ocean currents, gathering into vast gyres, slow-moving whirlpools like the infamous Great Pacific Garbage Patch, a floating accumulation the size of countries, shimmering beneath the sun like a mirage of our own creation. But plastic doesn't simply float. It sinks, fragments, and enters the food web. Tiny plankton mistake it for food. Small fish eat the plankton, larger predators consume the fish. And so, the plastic moves up the chain, molecule by molecule, until it reaches the dinner tables of those who made it. It has been found in salt, in shellfish, even in human bloodstreams. The ocean's pollution has become part of our biology. This is the quiet paradox of the sea. It gives endlessly, and so it absorbs endlessly. It takes our waste, our heat, our chemicals, our noise, and holds them until it can hold no more. Entire regions of water now suffer from oxygen depletion, known as dead zones, places where life once flourished but can no longer breathe. Nutrient runoff from agriculture fuels massive algae blooms. When those blooms die and decompose, they consume the oxygen around them, leaving behind only silence. Fish flee, corals suffocate, and ecosystems collapse into stillness. There are over 500 known dead zones across the globe, some stretching for thousands of square kilometers. They are invisible from above, just as most of the ocean's wounds are. The water still looks blue, still moves with grace, but beneath that beauty lies exhaustion. Noise, too, has become a form of pollution. The constant hum of ship engines, the pounding of seismic exploration, the low-frequency roar of propellers, all reverberate through the water, drowning out the natural songs of whales and dolphins. Sound travels farther in the ocean than light ever could, and so this mechanical symphony reaches even into the deepest canyons, filling the silence where once there was communication. For creatures who navigate, hunt, and speak through sound, noise can be as deadly as poison. Chemical contamination follows the same unseen path. Mercury, oil, pesticides, and heavy metals seep into the sea, binding to plankton and accumulating up the food chain. Whales, apex predators, and even seabirds now carry in their tissues the invisible legacy of human industry, toxins that travel through generations like unwelcome inheritance. The ocean, once the world's purifier, is slowly being turned into a mirror of our excess. And yet, the story is not without hope, because within every crisis lies response, and within every wound, the possibility of healing. Across the world, communities, scientists, and innovators are learning how to reverse the damage. They are turning waste into resource, developing biodegradable materials, building machines that skim the surface to collect plastic, and designing microbes that can break it down from within. The sea, given a chance, responds with astonishing speed. Where marine protected areas have been established, fish populations rebound within years. Coral fragments transplanted onto damaged reefs begin to grow again, rebuilding the architecture of life. And as nations reduce fertilizer runoff and regulate coastal pollution, dead zones shrink, their oxygen returning like breath after a long silence. The ocean's patience is vast, and its forgiveness even more so. Still, change must come from respect, not rescue. We cannot save the ocean as if it were separate from us. We can only remember that we are part of it, that every product we use, every choice we make, flows back to the same place where the tides begin. To heal the ocean is to heal our reflection within it. Imagine standing on a beach after a storm. The shore is scattered with driftwood, seaweed, and debris, evidence of both destruction and renewal. The waves do not judge what they bring. They simply return it. In that motion lies a lesson. What we send out will always find its way back. The sea does not ask for perfection. It asks for awareness, to pause before we discard, to design without harm, to move through the world as though our footprints extend into the tide, because they do. If the ocean could speak, it would not cry out in anger, but in fatigue, a tired whisper, asking us to remember the harmony we once shared. And if we listen, truly listen, we might hear what it's been saying all along, that the future of the sea is not written in salt or current, but in the choices we make each day above it. The ocean has absorbed centuries of human history, our progress, our pollution, our dreams, but it still holds more capacity for renewal than destruction. It is not too late to turn our gaze from consumption to coexistence, from indifference to care. The tides are moving, and we can still move with them, for the ocean, like time itself, forgives, but only if we remember to listen while it still breathes. What do you think the ocean would say if it could speak? Share your reflection and join the movement to protect our blue planet, not as visitors, but as guardians of the only world where water and life endlessly flow. Even after centuries of change, the ocean still remembers how to heal. When given time and space, it rebuilds itself quietly, persistently, the way a wound closes under sunlight. Among its most powerful agents of renewal are the coastal ecosystems that stand between land and sea. The mangroves, salt marshes, and seagrass meadows, the green borders of the blue world. They are not just habitats, they are defenses, lungs, and libraries of carbon, storing the planet's history grain by grain. In the tangled forests of mangroves, roots rise from the mud like the fingers of the earth itself. They filter the salt, trap sediment, and slow the waves that would otherwise erode the coast. To walk among them is to walk through a breathing machine, each branch a conduit of air, each leaf a small factory of oxygen. When storms rage and tides surge, mangroves absorb the impact, shielding villages, coral reefs, and even entire cities from destruction. Their roots cradle the young fish, crabs, shrimp, all finding shelter in the stillness between tides. It is easy to overlook them, to see only a swamp or a forest of tangled roots, but within that complexity lies the key to resilience. Mangroves store up to 4 times more carbon than tropical rainforests, burying it deep in their soils for centuries. They are nature's accountants, balancing the climate through quiet accumulation. Every leaf that falls becomes sediment, every root that dies becomes the foundation for new growth. In their patience, they teach what balance truly means, that strength lies in interconnectedness, not isolation. Beside them, in calmer waters, stretch the salt marshes, vast plains of reeds and grasses that sway with the rhythm of the tide. Their roots weave through the mud, creating a living barrier that prevents erosion and filters pollutants from the water. Each tide brings nutrients, each retreat takes waste away, and in that exchange, the marsh thrives. When the sun sets, the air hums with insects, and migratory birds descend by the thousands, their wings catching the light like brief reflections of the sky. To stand at the edge of a salt marsh is to see stillness in motion, a place where time moves in cycles, not lines. But perhaps the most graceful of all are the seagrass meadows, the ocean's hidden gardens that ripple beneath the surface. They grow in shallow, sunlit waters, anchoring themselves to sand while sheltering life from the waves. Seagrasses are among the fastest carbon sinks on Earth. They capture carbon dioxide directly from the water, lock it away in their roots and sediments, and in doing so, clear the very medium they inhabit. Where they grow, the sea brightens. The water becomes clearer, the oxygen richer, the ecosystem calmer. These blue forests, mangroves, marshes, and seagrasses work together like organs in a single body. They breathe, absorb, and filter for one another. The detritus from mangroves feeds the marsh. The nutrients from the marsh nourish the seagrass. The seagrass stabilizes the sea floor, protecting the roots of the mangrove. Each part depends on the others, a seamless circle of renewal written in soil, salt, and tide. But like all living systems, they are vulnerable. Dredging, pollution, and coastal development have destroyed over a third of the world's mangroves and seagrass meadows in just a century. Rising seas drown marshlands faster than they can adapt, and when these ecosystems die, their stored carbon escapes, turning the lungs of the planet into sources of heat. It is an invisible tipping point, a reminder that destruction and preservation are only a breath apart. Yet hope lives here too. All around the world, restoration efforts are beginning to reverse the damage. Volunteers replant mangrove saplings along eroded shores. Scientists transplant seagrass blades one by one into sandy bays, and within months, life returns. Fish schools shimmer through the roots again, crabs rebuild burrows, and the water clears, as though recognizing itself once more. The ocean, it seems, only needs an invitation to begin healing. In Florida, in Indonesia, in Kenya, and across the coasts of Vietnam, entire communities have learned to work with the tides instead of against them. They farm oysters and seaweed alongside mangroves, harvest salt without draining wetlands, and treat the coastline not as property, but as kin. It is a shift from ownership to stewardship, from extraction to relationship, and that shift may be the most important restoration of all. Scientists now call these areas blue carbon ecosystems, not because of color alone, but because they represent hope, a living solution born from the wisdom of the earth itself. By restoring them, we not only protect wildlife, but also slow the pace of climate change, filter our water, and give the planet room to breathe again. It is one of the rare stories where every act of healing multiplies. If you ever stand within a mangrove forest at high tide, you'll hear it, a sound unlike any other in the world. The soft bubbling of roots, exhaling oxygen into the water, the rustle of crabs climbing trunks to avoid the rising tide, the whisper of leaves brushing against wind and wave. It is the sound of balance returning, a small, quiet symphony of life rebuilding itself, note by note. And maybe that is what the ocean has been teaching us all along. That healing is not dramatic, it is steady. That resilience is not loud, it is patient. And that regeneration begins wherever we choose to protect what remains. Because in the end, the sea does not need saving. It only needs time to remember itself. And we, the children of its tides, must learn to give it that time. The deeper we descend, the stranger and more wondrous the ocean becomes. There, beyond the reach of sunlight, in the cold black chambers of the deep, exist creatures so alien that they seem born from imagination rather than earth. Yet each one is a living answer to the oldest question life has ever asked. How can I exist in darkness? This is the midnight zone, a realm of quiet extremes where pressure crushes, light is scarce, and warmth is only a memory. But in the absence of sun, life has found its own radiance. Bioluminescence, the ability to create light from chemistry, is not a rarity here. It is the rule. More than 80% of deep-sea species glow in some form, turning the darkness into a slow-moving galaxy of living stars. Tiny plankton flicker like sparks, jellyfish pulse in blue and violet halos, and fish shimmer with internal lanterns that flash in secret codes. This light is not decoration, it is survival. It attracts prey, confuses predators, and guides mates across the abyss. In the deep sea, light is life's language, each glow a sentence in the long story of evolution. Among these creatures drifts one of the ocean's most mysterious hunters, the anglerfish. Its body is small, but its strategy is ancient. A bioluminescent lure dangles from its forehead, glowing in the dark like a tiny moon. Unwary fish swim closer, drawn to the light, and in an instant, the anglerfish strikes, swallowing them whole. Its mouth is lined with translucent fangs, its stomach stretches to hold prey twice its size, and yet, in this world of scarcity, every meal is an act of luck as much as skill. Even more strange are its rituals of reproduction. The male anglerfish, small enough to fit in the palm of a hand, finds a female and bites into her body not in attack, but in union. Over time, his organs dissolve, his body fuses with hers, and he becomes part of her, a permanent companion, sharing her blood and giving her the means to reproduce. It is one of the strangest forms of love in nature, emerging so complete that individuality itself disappears. Nearby, other giants drift through the void. The giant squid, with eyes the size of dinner plates, moves like a phantom through black water. Its tentacles, lined with hooks and suckers, can reach lengths over 10 meters, grasping prey with the precision of a machine. For centuries, it was myth, the kraken, the monster of sailors' tales, until cameras finally captured its existence in the early 21st century. Even now, it remains elusive, living at depths where no human can stay for long. And deeper still, the colossal squid, even larger than its cousin, haunts the Southern Ocean beneath Antarctica. Its beak, the largest of any invertebrate, can shear through bone, and its glowing eyes are adapted to the faintest glimmers of bioluminescent prey. Yet, despite its monstrous scale, it is not an aggressor. It is a survivor, built by the same logic that shapes every creature here. Efficiency, patience, silence. Every organism in the deep sea must make do with little. Food is rare, light is fleeting, warmth is a distant memory. But scarcity breeds innovation. Some fish compress their bones to withstand pressure. Others use transparent bodies to avoid detection. Many survive on marine snow, a slow rain of organic particles drifting from the world above, tiny remnants of life falling through miles of darkness, feeding a realm that has never seen the sun. To them, this snow is abundance, proof that even death in one world sustains life in another. In this abyss, beauty takes on a new meaning. The creatures are grotesque, yet elegant, their forms shaped by necessity rather than design. The vampire squid, for instance, with its webbed arms and cloak-like membrane, is not a predator, as its name suggests. It floats gently through the water, feeding on detritus, particles of dead matter suspended in the dark. It survives not through violence, but through patience. Its bioluminescent tips flicker like embers, as though carrying a fragment of ancient fire into eternal night. When submersibles descend into this world, their lights reveal what may be the closest thing we have to an alien planet on Earth. Creatures glide past transparent, luminous, fragile, as if made of breath instead of flesh. Every shape, every movement is unfamiliar, and yet, beneath the strangeness lies perfect adaptation. Here, evolution is sculptor, artist, and survivor all at once. What is perhaps most humbling about the deep is not its mystery, but its calm. Despite the darkness, despite the weight of 1,000 atmospheres, it is a place of order, of quiet function. Predators hunt, scavengers feed, organisms glow, each fulfilling its role with precision born from necessity. There is no waste, no chaos, only rhythm. Even decay becomes creation, and somewhere in that balance, you can feel the wisdom of the planet itself. It reminds us that life does not need sunlight or comfort to exist. It only needs opportunity and patience, In that way, the abyss is not a void. It is a reflection of persistence, life stripped to its essence, continuing simply because it can. If we could see this world without fear, we might recognize ourselves in it. The same desire to endure, to find light in darkness, to adapt to what cannot be changed. The deep sea is not distant from us. It is the origin of us. The same molecules that drift there once gave rise to every heartbeat on land. So when you imagine the ocean's deepest places, don't picture emptiness. Picture galaxies of living stars, creatures born of silence and chemistry, surviving not in spite of darkness, but because of it. The deep is not the end of life. It is the proof that life has no end. Across the blue planet, invisible highways crisscross the sea, routes made of current, moonlight, and memory. No signs mark them, yet millions of travelers follow them each year. Turtles returning to their birthplace, whales singing across hemispheres, salmon climbing rivers that raised them, each guided by senses older than humanity itself. The sea has never forgotten its directions. It still follows the pull of gravity, the scent of the wind, the whisper of the moon, and perhaps so should we. Not to conquer, but to find our way back to harmony with the tides that made us. Good night, and see you in the next video.